It's kind of the same, except we're saying we have 100 trials and we're varying the probability, right? Otherwise, it's the same. We want to produce the same curve where we want like the probability of rejecting the null hypothesis, and that would depend on the probability. So as you saw, if the probability is more different from 0.5, then you have a higher probability of rejecting because it's easier to see evidence against the null hypothesis if the probability is really lopsided, right? So like all this is like programming, right? So here we want to again do as apply, except we want to supply a vector of probabilities instead of a vector of all tosses. So because this always goes to this, right? So the first argument here always goes to the first parameter here. What we need to do is we need to like change the order here in order to set things up. This is the way we were working. So I'll just do prob reject 2. So that's like not a very creative name, but so that's going to be like a prob reject 2, and then I'll just change the order. So this is going to be prob, and this is going to be and tosses. But other than this, nothing changed, right? And now I'm gonna say all prob, right? And I'll make all prob be like sequence. So I'll start with 0 and I'll end with 1, and I'll do steps of like 0.05, right? And now I'll say all prob reject again. That's now going to be sapply all.prob. The function is prob reject 2. And here we now say that we want to supply the tosses, which is 100. Right? That's it. So now that we got that, we can run it, see that it works. It didn't work. Oh, I didn't define it yet. So all prob reject is now like this. Okay, so it's 1 when the probability is 0, which makes sense because like out of 100, if you get like all tails, obviously the coin is not fair.
Right.
And then it goes to close to 0 when the coin is fair.
Okay.
Okay, so now like again, just put it in a data frame. So I'm just copying and pasting. So now here we have like prob, and that's going to be all prob. So that's going to be our x-axis. The order doesn't really matter. And then prob reject is the same. And now I'll just copy this as well and change it. So here we're saying prob reject yes. So x is going to be now prob. Here I missed a period. So x is going to be prob, and y is going to be prob reject. And let's run this. And what we get is this kind of thing, right? So kind of if the probability is far away from 0.5, then we have a very high probability of rejection. If it's really close to 0.5, we have really low probability of rejection.